Let's design a factorial function recursively. Factorial in math is defined or using the notation exclamation mark. So 2 factorial means 1 times 2. 3 factorial means 1 times 2 times 3 and the like. So up to n we keep multiplying from 0. In math 0 factorial is defined as 1. 1 factorial is also 1. Based on those trivial or base cases, factorial n is defined such that it multiplies 1, 2, 3, and all the way n minus 1, and then n is the n factorial definition. So I looked up the Google search and found a few points for assertion purpose. So here factorial 5 is a 120, factorial 10 is a 3,628,800. Those are the couple of points we are going to verify that. So here in recursive function design for factorial function, so we go through 3 steps again. First step, solve for trivial size. The trivial size when 0 factorial is 1, 1 factorial is 1. Those are definition from math. So step 2, assume we know that n minus 1 factorial is available. We assume n minus 1 factorial, suppose that that is m. Suppose n minus 1 factorial is m, then solve n factorial using m, which is n minus 1 factorial, and some known facts about the property of a factorial. So that's step 3. So in assumption is that 1 times 2 times all the way n minus 1. This is a solution for n minus 1. In step 2 of assumption, let's assume we know this is m. Then how do we solve for n factorial? Utilizing m and known fact. Known fact is that if we multiply n to m, that is n factorial. That's a known fact. So let's translate those findings into program. So as a prototype of the function we are going to define, let's have int return type and fact, and then integer n is provided. Of course, if we give a very big n, we will have a huge value. That value may exceed the range of int can represent. Int can represent only up to about 2 billion. So if factorial is over 2 billion, this will not work. In that case, we'd better have a double there. But for designing purpose, small numbers, let's just keep int at this moment. Then function design recursively, int factor, and the integer n is provided. Then we want to compute n factorial. Of course, on those functions, we didn't do validation of n. So in this power function, we want to validate that n should be non-negative. 0 is allowed. In some of integers also, you want to validate that n should be non-negative and the like. So anyway, let's add here assertion that as a validation, n should be non-negative. Then that would work. To use assert function, we should include a cassert library for that. So that's just the input validation is there. Then first step of a recursive function design, solve for trivial size. If n is 0 from math, 0 factorial is 1. And then if n is 1, 1 factorial is 1 as well. So trivial case is solved. Then assume we know the solution for n minus 1 size. So which is if we call factor function with n minus 1, that is a solution for n minus 1 size, which is n minus 1 factorial. Then how do we compute the n factorial out of that? We just multiply n to it, then that is a n factorial. So we return that. So that is a step 3, utilizing assumption. Then how do you solve for size n? Multiply n. So we finish the recursive function design of a factorial function. So let's compile the program and then run. Then minimally those two assertions are satisfied. So we have completed the factorial function design recursively.